Hello everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll go through this formula and equations exercise, work number 4. This is associated with the combined science 5129, the chemistry component of which requires students to calculate the relative molecular mass prior to the next topic on calculations. So relative molecular mass is defined as the sum of the relative atomic mass. So basically, you need to total up the relative atomic masses, and relative atomic mass is for the respective individual elements in the periodic table of each element in the formula unit. Okay, so you basically sum up the individual relative atomic mass depending on how many of each you have. Okay, so for instance, chemical formula here, H2SO4 is what you call sulfuric acid. Is one of the three very common acid that you must know the name and you must know the formula. When someone says sulfuric acid, they mean H2SO4, 2 hydrogen, 1 sulfur, 4 oxygen. It also means that when someone gives you the formula, you know the name is sulfuric acid straight away. So there are 2 hydrogen, 1 sulfur, 4 oxygen. So relative molecular mass, the mass for 1 hydrogen is just 1. In your periodic table, you have hydrogen 1, 1. We are looking at this value on top there. Oops, sorry, not the one on top, but the one at the bottom, because that is the relative atomic mass as given and as shown in your periodic table. They say the number at the bottom is relative atomic mass. The number on top is what they call the protons or atomic number. That is as given in the periodic table. Then you have sulfur, which is 16 and 32. So we're looking at this 32 because we are summing up the relative atomic mass. For oxygen is 8 and 16. So we're looking at this 16 at the bottom. So there's how many of these number 1 here? There is 2 hydrogens. So 2 times 1. There's 2 hydrogens, each of which is 1. And then you add up. Sum means you add. Okay, you plus. There's 1 sulfur. So 1 times 32 there. So 1 times 32, it could be 32 times 1, it doesn't matter. As long as how many you have 1 sulfur. What is the mass for 1 sulfur? You look at the periodic table, you have relative atomic mass. Now you have 4 oxygens, so 4 times 16. I should really have put down my working on the working side, so that to show 2 times 1, 2 hydrogens, plus, because it's the sum, 32 times 1, because I have 1 sulfur, each of which is 32. 16 is the mass for 1 oxygen, and I have 4 oxygen in H2SO4. Sum all of this up onto your calculator. 1 times 2 plus 32 times 1, or 1 times 32, doesn't matter, plus 16 times 4, I get 98, just like that. Okay, these are things you should be able to key into your calculator correctly and very quickly as well. Moving on to the next one, this is magnesium chloride. So I hope you know from the previous topic how to name them. This is no longer chlorine because it's Mg2 plus and Cl minus. Just to remind you how to construct the formula. The charges is the valency, is the combining power. We just take the value. It's a group 2 metal, loses 2 electrons to get to a completely filled outer shell, a full outer shell. By losing 2 electrons, the valency is 2 from the charge there. A group 7 element will gain 1 electron to complete the outer shell, so they just have 1 based on the charge being -1. When you do crisscross, do not crisscross the ions. Instead, you are crisscrossing the valency or the combining power, basically the value, the number. The one on the right goes to the left, the one on the left goes to the right. What this means is how many. You have 1 Mg2 plus because everything on the left belongs to the Mg2 plus, everything on the right belongs to the Cl minus. You have 2 of it, so you got Cl minus and Cl minus. That's why the formula is Mg, 1 of it and 2 of the Cl. There's magnesium chloride. So from the periodic table, you got 1 magnesium. The magnesium shows the relative atomic mass is 24 because relative atomic mass is that number at the bottom in the periodic table. This is not international standard. This is periodic table standard. So we're looking at that being the relative atomic mass. 24, there's 1 of it. And then chlorine, there's 2 chlorine. The relative atomic mass 35.5 there. So 24 times 1 plus 35.5 times 2, I get 95. Next up is calcium carbonate. As you know, this is called calcium carbonate because it consists of Ca2 plus and CO3 2 minus. As you can see, the charges are the same, so one of these and one of these will mean the charge cancel out. Instead of 2:2, instead of 2 calcium and 2 carbonate, the simplest ratio is 1:1. So 1 calcium is 1 times 40, and then 1 carbon is 1 times 12, and then I have to sum them up. Remember, relative molecular mass is the sum of the individual relative atomic mass depending on how many you have, and I also have 3 oxygen, so 3 times 16 there. Press your calculator. 1 times 40 plus 1 times 12 plus 16 times 3, I get 100. Next up, we have this compound called ammonium carbonate. Hope you can realize that that is ammonium. Ammonium is an ion. Ammonium ion is NH4 plus. Ammonia, NH3, is a molecule. Be very careful between ammonia and ammonium. Ammonia is a molecule that you need to know the formula from your structure and bonding under simple covalent molecule. Ammonium is an ion, is NH4 plus, the charge is +1, there are 4 hydrogens. CO3 2 minus is what you call carbonate. Carbonate is CO3 2 minus. So when you have NH4 plus and CO3 2 minus, 1 comes from the charge, which is just a number. 2 is the valency for carbonate based on the charge being 2 minus. We just look at the number. When you do crisscross, you are crisscrossing the number. The combining power goes to the other side. So 1 goes to the right, 2 goes to the left. What this means is I have 2 of this thing on the left, I have 1, I have 2, and then I have this 1 of this thing on the right. So +1 and +1 is give me +2. Cancel out 1 of these, which is -2. Overall compound has no charge. Ammonium carbonate is going to be NH4, 2 of them, CO3. The oxygen is capitalized, the numbers are subscripted to tell you how many number of each atom. Ammonium carbonate, that's the name, ammonium carbonate. So you have this thing in a bracket, that means 2 of this NH4 plus, 2 of that, 2 of that. So I'll do the one inside the bracket first. I have 14, which is the mass for 1 nitrogen. I have 4 hydrogen, each of which has a mass of 1. This is inside the bracket. 1 nitrogen, which is 14 times 1. There are 4 hydrogen, which is 4 times 1. Add them up. But I have 2 of them, 2 of this whole unit. I have 2 of them. This means this, 2 of it. So whatever mass this is, I must multiply by 2. I'm done with the NH4 twice meaning 2 times. Now I have 12 times 1. For the carbon, I have 1 carbon. I have 3 oxygen. So 16 times 3. Altogether, I would do this on my calculator first. 14 times 1 plus 4 times 1, I get 18. Do equal in your calculator first and then multiply by 2. 18 times 2 is 36. And then plus 12 times 1 plus 16 times 3, I get 96 altogether. Okay, on to the next one. This is called sodium oxide. Remember, oxygen in a compound with a metal. This is ionic compound. It has got Na plus as well as O2 minus. In fact, it got 2 Na plus and 1 O2 minus. So 2 times sodium, 2 times 23 plus 16 times 1. Do not use the wrong value. Make sure you use the relative atomic mass. I get 62 there. Next one, CCl4. This is not an ionic compound because it's between a nonmetal and a nonmetal. This is a covalent compound. As you know, covalent compound has low melting and boiling point because it's a covalent compound. They share electrons between the nonmetal and nonmetal. So what happened there is it will not conduct electricity at all. Cannot conduct electricity at all. It's an insulator. And it also has low melting and boiling point. 1 carbon is 1 times 12 plus 4 chlorine, 4 times 35.5. Do that on your calculator. I get 154. So that's what I put in there. Number 7, so we have this thing called lead 2 carbonate, because as you know, we have carbonate ions, which is CO3 2 minus. The charge is 2 minus. The 3 refers to 3 oxygen at the bottom. So these are the kind of ions from that table which are not given in exam or in test. Looking at it, you have one of that carbonate ion, so one of that 2 minus means that you must have Pb2 plus, and Pb2 plus is your lead 2 carbonate. So looking at that, counting the atoms, so you have 1 of Pb, so Pb is in group 4 in the periodic table, so there's 207 times 1 plus 12 times 1 for the carbon, and then 16 times 3 for the oxygen. So put that into your calculator, get 207 plus 12 plus 16 times 3, you get 267. Next up, you have 3 of that nitrate, meaning you have NO3 minus, NO3 minus, and also NO3 minus. Minus 1, minus 1, and minus 1 give you altogether minus 3, but you only have 1 of that ion, so that means for the charge to cancel out, that must be ion 3 plus. If you do the crisscross, the 3 valency and the 1 valency for the charge, so if you have Fe3, oops, I ran out of space there. I really run out of space everywhere actually. So Fe3 plus, NO3 minus, 1 and 3. We always label our stuff, and when we crisscross the valency, meaning the number and not the ions, and that have been one of the many mistakes that I have seen when I mark the work. So this means there's 1 of that Fe3 plus, and then there is 3 of that nitrate. So altogether, in that bracket, there's 3 of that nitrate, so there's 3 nitrogen, and there's 3 times 3, which is 9 oxygen. So iron is element number 26 in the periodic table. Element number 26 means the atomic number or the proton number is 26, but we're dealing with Mr, which is to do with mass. Mass is to do with the sum of the relative atomic masses as defined in your notes, as defined in the syllabus. There's 1 iron, so 56 times 1, plus you have 3 times the nitrate, so 3 times whatever the NO3 is. NO3 has got 14 times 1 for the 1 nitrogen, and you got 3 oxygen, so 16 times 3 there. So that is NO3 because there's 3 oxygen and 1 nitrogen. The whole sum of it, I have 3 lots of it, so I multiply the whole thing by 3. You got to know how to press your calculator. If I were you, I would do this bracket first. 14 times 1 plus 16 times 3, I get 62. 62 times 3, because I have 3 of that nitrate, I get 186, and then plus 56 times 1, I get 242. This kind of thing needs to be done relatively quickly once you know what is going on, okay? Next up, zinc 2 plus and SO4 2 minus. You gotta know this kind of formula. That's how you get the correct formula to begin with. Zinc is element number 30. The relative atomic mass is 65. There is 1 zinc. There is 1 sulfur. There is 4 oxygen. So they give me 161 altogether. This next one is called lithium nitrate. Lithium is a group 1 metal. Group 1 metal loses 1 valence electron to get to a fully filled outer shell, and you get NO3 minus, which is the nitrate ion. So lithium has a mass of 7, 1 lithium, and then 1 nitrogen, which is 14, and then 3 oxygen, which is 16 each, so 16 times 3 there. So I get 69. So that's it for that question part A. Question part B. So as you know, oxygen is a diatomic molecule. That is from part 1 of the lesson, and is also from the covalent bonding topic. As you know, oxygen, group 6, not fully filled outer shell, share 2 out of the 6 valence electrons, and then you get to a fully filled valence shell. Do not forget that you still have 4 more electrons in the outer shell. that are not used for forming covalent bond, but you got to show them that there are 6 original, share with 2 from the other atom. Now it has 8 electron, which is fully filled out the shell after you share these 2. The same thing for the 6 crosses, share 2, and you get to a fully filled outer shell, double covalent bond. Each covalent bond is 2 electrons. 2 covalent bond means 4 electrons being shared. So the formula of oxygen is always diatomic, O2. So there's 16 for 1 oxygen. 16 times 2 is 32. The MR of oxygen is 32 because there's 2 oxygen. Sodium chloride is your case study from ionic compound, ionic bonding, and also from your crisscross. As you know, group 7, they gain 1 electrons to form negative charge, and then negative 1 because you only gain 1 electron. Group 1 lose 1 valence electron, give you a +1 positive charge. So altogether, crisscross will tell you you have 1 of each, +1 cancel out -1 exactly. The overall compound has no charge at all. So you got 23 for the sodium, you got 1 of it. You got 35.5 for the chlorine, and you got 1 of it. And you total up to 58.5. That is the MR for sodium chloride. Ammonium ion. Ammonium is an ion. Ammonia is NH3 is a molecule from covalent bonding. This is an ion. NH4 plus, the sulfate has a new spelling, SULFATE. So what happened is 1 and 2, that is the valency. And then we talk about how many of the ions we want. So, we crisscross the valency, so 2 and 1. So that means I have got 2 of the NH4 plus, and I've got 1 of the SO4 minus. Make sure you know how to get that, and make sure you know how to write these. The numbers are at the bottom as I've gone through in work 1, work 2, and work 3. So I've got 2 of that ammonium ion. So I've got 2 nitrogen, 8 hydrogen, 1 sulfur, and 4 oxygen. So you can think about 2 times 14 for the nitrogen, 8 times 1 for the hydrogen, 32 times 1 for the sulfur, and then 16 times 4 for the oxygen. At this stage, you can't be pressing your calculator incorrectly because that is your primary school mathematics, how to press things into your calculator. So make sure you know how to do those without any mistake at all. So that's the end of this work 4, and I hope that has been useful. So make sure you click the button on the bottom right, subscribe to the channel, share the channel widely with your friends, chat group, other people who might benefit from these videos, and follow me at ptet.chemistry on Instagram, Facebook, and Twitter, and I'll see you in the next tutorial video. Make sure you ask any questions if you got any.